So, we're ready. All right. So, good warm-up coming out of the video that you were supposed to watch in the last week. Find me what X is and find me what Y is. Go. So, from the video that you were supposed to watch sometime in the last week, what is the ratio of the sides in a 45-45 right triangle? 1, 1, square root of 2, right? So 1 to 1 to the square root of 2, right? Okay? So the 1 and the 1 are the legs, yes? And the square root of 2 is the hypotenuse, okay? What's the hypotenuse in this example? 1. So now somehow I've got to make square root of 2 become 1. How can I make the square root of 2 become 1? Divide everything by the square root of 2. So if I divide here by the square root of 2, then I got to divide here by the square root of 2, then I got to divide there by the square root of 2. And so then this would be like X, what we wanted it. This one would just be like the other side. Right? And that would be 1. So that means that X then is 1 over the square root of 2. Well, that's great and all. And some people, like me, like, radicals downstairs. But most people, like me, don't like radicals downstairs. Okay? I'm kind of either way. Okay? Right? So if I don't like radicals downstairs, then I've got to take 1 over the square root of 2, and I got to multiply it by a fraction equal to 1, which is the square root of 2 over the square root of 2, and then I get the square root of 2 on top, square root of 4 on the bottom, which is 2. Depends on what we're talking about. Like if it's unit circle that we're talking about, then we would want the square root of 2 over 2. But if we were just like simplifying a fraction, we'd probably take either over. We're wishy-washy on it. We'll let you know if it ever would come up. Yeah? All right. Next one, what kind of a triangle is that? 30, 60, 90. What is the, I'm going to throw an X in here just so that we get in there. What is the ratio of a 30, 60, 90? 1 square root of 3 and 2. Okay? So that is short leg to long leg to hypotenuse. My hypotenuse here is 1. So again, how do I go from a hypotenuse of 2 to a hypotenuse of 1? Divide by 2. So then this would be the square root of 3 over 2, and this would be 1/2. Y here is the short one. So y here then would be 1/2, and x would be the square root of 3 over 2. Questions, comments, concerns, clarification? We'll come back to that in a minute. Today, what we're going to do is we are going to be developing the unit circle. So first off, we have to give a little background of the unit circle. Yeah? So the unit circle, the equation of the unit circle is x squared plus y squared is equal to 1. The true equation of the unit circle is that, but we just don't write the zeros. This is a circle centered at the origin with a radius of 1. That is the unit circle. It is 1 unit big. Centered at the origin with a radius of 1. What we know from our last unit is we know that any arc length on any circle is equal to the theta, the radian measure of that angle that you go through, times the radius. Well, if our radius is 1, what can you tell me about any arc length on this circle? So if we went like this, here, here, we call this theta. How long is this arc? Theta, right? I didn't hear you.
No, you're good.
It's theta. Or, more importantly, we call this t. So t would equal theta. So if you went 2 radians in terms of your central angle, your arc length would be 2 units long. If you went 1.5 radians, your arc length would be 1.5 units long. If you go 12 radians, your arc length is 12, and so on and so forth. Okay? That t value we call a wrap value, okay? Because it kind of wraps around the circle. And the endpoint of that wrap value gives you a coordinate. And that coordinate is on the unit circle. So that value is on the unit circle, which means that it would make this x squared plus y squared equals 1 equation be true. Okay? what this is saying. Each and every t value, rep value, corresponds to a point x comma y on our unit circle. And each t value also corresponds to a central angle theta, whose radian measure then would be t. So, if we're on the unit circle, the cosine of any angle, okay, remember, trig functions have their inputs as angles. The cosine of any function, and the abbreviation that we use is COS. Okay. The cosine of any function is equal to, is equal to the x value of that point. Again, provided we're on the unit circle. If we're off the unit circle, then these relationships do not work. Okay? This only works if we are on the unit circle. The sine of my angle is going to be the y value. The tangent of my angle is going to be the sine of my angle divided by the cosine of my angle, which then is y over x. Those three you have probably heard of before, because all of you made it through geometry to get to this point. So you probably have heard of SOHCAHTOA before, sine, cosine, and tangent. But there's three more in trig. Okay? All of them are paired up. Okay? So the 6 trig functions are all paired. Okay? The pairs are reciprocals of each other. Okay? All of them have to have a co in them. Okay? So tangent is paired with cotangent because we need a co. Okay? So cotangent, or COT, would be equal to cosine over sine, or simply x over y. So cotangent is the reciprocal secant and cosecant are reciprocals. Secant is the reciprocal cosine because it needs a co. Okay. So between sine and cosine has the co. So we have 1 over cosine or 1 over x. Cosecant is the reciprocal of sine. Oops, I forgot. Tap the brakes, Linz. I forgot. Let me get in here. Get all up in here. I forgot to give you what the abbreviation was of this one. SEC. SEC for secant. Cosecant is CSC. And so it would be 1 over y. Forgot about the abbreviation. Now, again, those only work if we're on the unit circle. Okay? So one of the problems that we could give you, or one of the flavors of problems that we could give you, looks like this. Is this really a possible point on the unit circle? Okay, so because if it is, we want to find the 6 trait functions for it. Okay? So the first thing that we got to do is we got to make sure that it's on the unit circle. We can't just say, well, yeah, it's on a circle, okay, but it could be on any circle. Only the relationships that we just learned work for the unit circle. So the first thing that we got to do is we've got to determine if it meets the qualifications set forth by the unit circle's equation. X squared plus y squared equals 1. So we take the x value, negative 5/13, square it. Take the y value, negative 12/13, square it. Add it together. Hopefully it equals 1. And we don't even need a calculator for it. Negative 5 squared. Anybody? Negative 5 squared. 25. 13 squared. 169. 12 squared. 144. The nice thing is, we already have common denominators. So we just got to add the tops. 25 plus 144. 169. So this is 169 over 169. Is that equal to 1? Yeah. All right. So we checked it. It is on the unit circle. So now those 6 relationships that we just talked about are all valid. We can use those because we're on the unit circle. So the cosine of t is going to be what? Negative 5/13. The sine of t is going to be what? We got negative 12/13. I thought you would answer it. That's why I did. Hold on. Okay. I just couldn't hear what the first part of what you said was. Okay? Tangent. What's tangent? Tangent is what? Sine over cosine, right? Which is y over x, right? So that becomes negative 12/13 over negative 5/13. Thinking back to 4th grade, how do I divide fractions? What? Keep, change, flip? Okay. Oh yeah, okay, I got you. I didn't remember what change was. Change the sign, right? Okay, so we keep the top one. Change the operation to multiplication. And do what with the other one? Flip it. So what do we get? 12/5. No? But it asked us to find all 6 of them, right? Okay. So the ones that we have to figure out yet are cotangent, secant, and cosecant. Which one's which? Or give me one. Which one's 5/12? Cotangent. Yep. Cotangent is 5/12. Give me another one. Say it out loud. Is which one? Secant? Okay. Could I write it as negative 13/5? Cosecant then. It's what? I missed the negative part the first time you said. It sounded like you had just said 13/12. And I'm like, whoa, they're not perpendicular. And there's our 6 trait functions. Okay? Good time. So what we're going to do now is we are going to make a unit circle. Okay? You are going to utilize this unit circle for approximately the next 4 months. Okay? Maybe even longer. Okay? So what I recommend for you to do is start on a complete fresh piece of paper. So nothing on either side piece of paper, because you're going to refer back to this numerous times within the next 6-7 months. Yeah. Okay. All right. On that piece of paper, as big as you can draw it, I need you to draw me a circle. Okay? So, as big as you can draw on your piece of paper, a circle, that will work. All right. So, on the unit circle, it's a circle with radius of 1. Okay, so that's still the unit circle. We still have x squared plus y squared equals 1. Okay. We're going to fill in the 16 nice, and I put nice in quotation marks. We're going to fill in the 16 nice points. Okay. So first off, calculators, put them away. We don't need them. We don't need calculators. Because calculators aren't going to give us the right answer. Okay? Because we want to be exact. Okay? We don't want to be rounded. Okay? We want to be exact. Okay? So, I'm going to give you the starting point. We together then are going to fill in the remaining 15. Okay? So the starting point for the unit circle is over here. It's at the point, the coordinates of the point are 1, 0. Because it's 1 unit straight to the right. That's our starting point, so that would be 0 degrees or 0 radians. It is also the ending point. So not only is it 0 degrees, but it is also 360 degrees. It is 0 radians, but it is also 2 pi radians. Yeah. So that's the whole circle, yes? Now let's take our circle and let's cut it in half. So what is half of 360 degrees? 180 degrees. Where would that be? Straight to the left. How many radians is that? Pi radians. What are the coordinates? Straight to the left. No? Just -1? -1, 0. Two of 16. Okay. Let's take our half and cut it in half. Degrees, 90. So that's going to be straight up. Radians, pi over 2, because it's half of pi. Coordinates, 0, 1. Good so far? Okay. Let's take our bottom half and let's cut it in half. 270 for my degrees. Radians. Halfway between 1 and 2. Three pi over 2. Coordinates. 0, -1. 4 of them done. Okay. Let's go back up to the top half of the unit circle. We cut it in half. Now let's cut our half in half. So what's 90 cut in half? 45. So this one is a 45-degree angle. Pi over 2 cut in half. Pi over 4. Now, we got to come up with the coordinates. And we want them to be 1/2, 1/2, don't we? But the problem with 1/2, 1/2 is it's not on the unit circle. So it can't be that. Okay? So let's do a little geometry here. If I take and I make a triangle out of that, what kind of a triangle did I just make? A right triangle. A what? A 45, 45, 90. What's the hypotenuse of my 45, 45, 90? 1, right? Because my unit circle has a radius of 1. It's almost as if we did this before. So what are the side lengths then? 1 over the square root of 2, or more importantly, square root of 2 over 2. So both of these are the square root of 2 over 2. I'm in quadrant number 1, so quadrant number 1 always has positive and positive coordinates. So this is going to be the square root of 2 divided by 2, comma, the square root of 2 divided by 2 for its coordinates. Now let's go into quadrant number 2. Quadrant number 2, the halfway point would be right there. So what's halfway between 180 and 90? 135? 135 degrees. What's halfway between 1/2 and 1. Three-fourths, right? So it's 3 pi over 4. Coordinates. No? Which one's going to be negative? The x. What about the y? Positive, yep. Because all of the coordinates in quadrant 2 are negative, comma, positive. Let's go to quadrant number 3. Halfway point is there. Halfway is 225 degrees. Halfway in radians. Halfway between 1 and 3/2. 5 pi over 4. Coordinates. What you got? Both negative. Yeah. Quadrant 4. Halfway. 7 pi over 4. Halfway. 345. 315 I like better. Coordinates. Go here. So now, the next one that I want to go to is here. This is at 30 degrees. Which means that this is what kind of the 30, 60, 90 right triangle. And the ratio was 1, square root of 3, and 2, right? But our radius is only 1. So that means my short side is going to be my hypotenuse is only 1. So that means my short leg would be, no, 1/2. My long leg, square root of 3 over 2. So the coordinates of that point would be what? Bingo. So this point right here would have the coordinates the square root of 3 over 2, comma, oops, I almost made it negative, comma, 1/2. And we said that that was 30 degrees. The only thing that we've got to do now is figure out what 30 degrees is in radians. Pi over 3? Pi over 6. Which one? Pi over 6. So now if I go into quadrant number 2, my coordinates are going to be negative square root of 3 over 2, comma, positive 1/2, because I'm in quadrant number 2. I'm 30 degrees short of pi, so that means I'm what? What's my degree measure? 150. I'm pi over 6 short of pi. 5 pi over 6. Explanation? What's pi in terms of 6? 6 over 6, right? Because it's 1. And if I'm 1/6 short of that means I'm at 5 pi over 6. Okay. If I go down to quadrant 3, now I'm going to be at negative square root 3 over 2, comma, negative 1/2. Now I'm 30 degrees more than 180 degrees. How many degrees would I be at? 30 more than 180. 210. I'm pi over 6 more than pi. 7 pi over 6. Yes? Okay. Now we go over to quadrant number 4. Now I'm going to be at the square root of 3 over 2, comma, negative 1/2. I'm 30 degrees short of a full circle. What do you got? 330 degrees. And I'm pi over 6 short of a full circle. 11 pi over 6. Because 2 pi would be 12 pi over 6. Short one makes me 11 pi. Okay? So now, let's switch this around. Let's go instead, let's go to here. This was 30 degrees. This was 45 degrees. That gap is 15. So this gap is also going to be 15. So that puts me at 60 degrees. Now, if I make my triangle, Now this is my 60-degree angle. Here is my 30-degree angle. I still have a hypotenuse / radius of 1. So which is which? 1/2 would be which one? The horizontal or the vertical? The horizontal. And the vertical would be square root of 3/2. So what would the coordinates of that point be? 1/2 times square root of 3/2. So they just flip-flop. The x and the y flip-flop. So then the only thing that we have left is what is the radian measure? Pi/3. Three more on the tail end. Next one's there. Negative 1/2, positive square root of 3/2. Degrees or radians? Two pi/3 is the radians. A 120 degrees is the degrees. Go down here to quadrant 3. Negative and negative. Now I'm 60 degrees more than 180 degrees. $240. I'm pi/3 more than pi, or pi/3. Last one. One-half comma negative square root of 3/2. Degrees, 300. Radians. I'm pi/6 short of 2 pi. Oh, I'm sorry, I said pi/6. Yes, pi/3 short of 2 pi is 5 pi/3. Okay. So that, ladies and gentlemen, is your unit circle. You get to use that going forward on homeworks and quizzes and things of that nature. Okay? Do not lose it. If you lose it, you got to make a new one. Okay? As we said before, you will have next week, Tuesday, a memorization quiz on the unit circle, where we will ask you in a shorter period of time, so that it's not a figure it out as you go along period of time. It is a memorization quiz because this is important to us. As I said before, we're going to use this for the next 6 months. Okay? So we need you to memorize it because it's going to make your life be easier. So you need next week, Tuesday, to reproduce the unit circle. Coordinates, radians, and degrees for each of the 16 points. Should only take you 3. Why should it only take you 3, Mr. Proka?
Because you know one quadrant.
If you know one quadrant, you know all the rest of the quadrants. Yep. So really, we're only asking you to memorize quadrant number 1. Okay? After that, you should be able to figure it out all the way around. Okay? On top of that, I will tell you, because you guys were so good today in your unit circle-ness, I will tell you that you will also, next week, Tuesday, need to memorize the 6 trig functions. The fact that cosine is x, sine is y, tangent is y over x, cotangent is x over y, secant is 1 over x, and so on and so forth.